Alright, lesson 6.8 is formulas for sine of alpha plus beta and sine of alpha minus beta. So right now, we've looked at the expansion, the identity for cosine of alpha plus or minus beta. That was cosine of the first angle measure times cosine of the second angle measure. Then we had to change the operation. So a plus inside the parentheses would change to a minus in the expansion. A minus inside the parentheses would change to a plus in the expansion. And then sine of the first angle measure times sine of the second angle measure. Now the expansions for the sine function. So the products never change. Sine of alpha plus beta. Sine of the first angle measure times cosine of the second plus cosine of the first angle measure times sine of the second. In the sine function, the operations stay the same, but what we multiply changes from the cosine identity. Sine of alpha minus beta, sine of the first angle measure times cosine of the second. Keep the operation the same. Cosine of the first angle measure times the sine of the second. So simplify as an exact value. According to the expansion, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first angle measure times the sine of the second angle measure. Now when you're done the expansion, you're taking the sine and cosine of each angle measure, but notice that alpha and beta have to be in each term. Alright, so sine and cosine of the angle measures, and then you take the cosine and sine, but you have to take the cosine and sine of the other angle measure that was given. Alright, so 2 pi over 3 is in the second quadrant. Reference angle of pi over 3. So positive square root of 3 over 2 times square root of 2 over 2. Cosine of 2 pi over 3, second quadrant, makes it negative. Reference angle of pi over 3. So negative half times square root of 2 over 2. Top times top, bottom times bottom. Top times top, bottom times bottom. And then we'll just make it into one fraction. Square root of 6 minus square root of 2 all over 4. So that would be the exact value. Here, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first angle measure times the sine of the second angle measure. Now these are both first quadrant angles, so referring to the chart, square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. Top times top, bottom times bottom. Top times top, bottom times bottom. So these angle measures have the same exact value. So A and B have the same exact value. The identities we can use in proofs, just like we did with the cosine functions. On the left-hand side, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first angle measure times the sine of the second angle measure. If you remember the three sort of steps, expand using the identity, determine the exact values where appropriate, and then in comes your algebra to simplify. Sine of 3 pi over 2 is negative 1, plus cosine of 3 pi over 2 is 0. On the left hand side we have cosine of x, and on the right hand side, or excuse me, we have negative cosine x on the left hand side, which is exactly what we were originally given on the right hand side. So we just proved the identity. For B, working on the left hand side again, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first times the sine of the second. And we're proving it's equal to negative sine x. Cosine of pi is negative 1. Sine of pi is 0. That gets eliminated. Sine times negative 1 would be negative sine x, which is what we had on the right hand side. So again, we proved another identity. Alright, so now alpha plus beta, same steps as with the cosine function. You have to tell me angle measures that add to 13 pi over 12. So let's do, I know 13 and 1 won't work, or excuse me, 12 and 1, because pi, it's in the wrong spot, pi over 12 won't reduce. So let me think of 9 plus 4 gives me 13. If I reduce these, I would have 3 pi over 4 plus pi over 3. So I'll go with that. Like we've talked about in class, we will tell you which identity to use. So I know I have to be adding the angle measures together. So sine of 13 pi over 12 is equivalent to the sine of 3 pi over 4 plus pi over 3. Using the identity, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first angle measure times the sine of the second angle measure. So now our steps for here, find alpha and beta. We'll tell you whether you have to add or subtract them. Expand using the identity. Your next step would be the exact values. So second quadrant angle, positive square root of 2 over 2 times a half plus negative square root of 2 over 2 times positive square root of 3 over 2. Top times top, bottom times bottom, top times top, bottom times bottom. Putting them together, square root of 2 minus square root of 6 all over 4. So this is the sine of 13 pi over 12. Sine of 13 pi over 12 using the difference formula. Now we already know what our answer should be. It should be square root of 2 minus square root of 6 all over 4. We're just going to prove it using the other identity. So now we need some angle measures that subtract to 13. So I could do 16 pi over 12 minus 3 pi over 12. 16 minus 3 gives me my 13. When I reduce these, dividing the first by 4 would give me 4 pi over 3 minus pi over 4. So this one will work. Sine of alpha minus beta. Using the expansion, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first angle measure times the sine of the second angle measure. Exact values, 4 pi over 3 is a third quadrant angle, so both sine and cosine will be negative. Negative square root of 3 over 2 times square root of 2 over 2 minus negative 1/2 times square root of 2 over 2. Top times top, bottom times bottom. Minus a negative would make this a plus. Top times top, bottom times bottom. And then if I were to just rearrange the order, putting the positive square root of 2 first, minus the square root of 6, all divided by 4. It verifies the answer we already found in part A. Okay, last one, 7 pi over 12. So let's go with the easy ones. 3 plus 4 gives me 7. Both of these will reduce to first quadrant angles. So pi over 4 plus pi over 3. Sine of pi over 4 plus pi over 3. Using the identity, sine of the first angle measure times the cosine of the second angle measure. Keep the operation the same. Cosine of the first angle measure times the sine of the second angle measure. Determining the exact values, square root of 2 over 2 times a half plus square root of 2 over 2 times square root of 3 over 2. Top times top, bottom times bottom. Top times top, bottom times bottom. So my exact value, just write the final answer as one fraction. Square root of 2 plus square root of 6 all over 4. your homework. Complete the 6-8 worksheet. Homework quiz tomorrow.